The Human-Robot Interaction Lab Sønderborg has basically three objectives: provide a platform to anchor collaborations with external partners, support student projects, and allow us to carry out our own experiments. As to our collaborations, we work, for instance, with the University of Innsbruck on the role of robot gaze in collaborative construction.
Oh, perfect.
With researchers at Stanford, we analyze what car navigation systems should say to increase users' trust.
That's the most bizarre question I've ever heard from a car.
With Katrin Nohan from Heriot-Watt University in Edinburgh, we look at the effects of the timing of robots' nonverbal behavior.
Jawohl. Und das ist eine Schachtel mit einem Deckel, die kann man aufmachen, die kann man wieder zumachen.
The second objective is to provide students with tools to carry out their own projects. On our lab website, students can download manuals and software for their experiments, and they can also borrow our robots for their projects, which have already led to master theses and even to some publications. The third objective of our lab is to carry out our own studies. For our own experiments, we either use our own robots to investigate interactional effects of aspects of language, or we work with a care robot, which has been jointly bought by the Maersk McKinney Møller Institute and the DTI in Odense, and which comes over to Sønderborg regularly for HRI experiments. In general, when we're designing and implementing robots, we need to know which human capabilities and which aspects of human interaction we need to endow our robots with, and which we can simply ignore because people will just adapt to them. One such issue is the timing of the robot's behavior, especially the synchronicity of its actions. One scenario we're working with is a use case for the care robot in which it drives around, for instance in a hospital or care facility, and carries out medical measurements using non-invasive optical sensors. In our lab, we tested two different ways in which the robot drives up to people and asks them to place their fingers into the sensor. In one condition, it drives up to the participants, says, "Please put your finger into the sensor," and then extends its arm with the sensor. In the second condition, the robot carries out all actions simultaneously. This is an example of the first condition in which the robot's actions occur in sequence.
Please put your finger into the sensor so that I can measure your blood pressure. Thank you. That's it already. Please put your finger into the sensor so that I can measure your blood pressure. Thank you. That's it already.
Now, when we look at participants' behavior, we can see that they have problems in condition 1, but not in condition 2. Interestingly, people thought that the robot in condition 1, in which it carried out all actions separately, was in fact more intelligent. We think that the reason is that participants become more aware of each action if the robot carries them out in sequence. However, participants' behavior clearly shows that the robot with synchronized behaviors causes many fewer problems for them. This discrepancy between what people expect how they will respond and how they really respond to a robot is the reason why we need to carry out experiments. And this is what we do in our Human-Robot Interaction Lab in Sønderborg.